Welcome to the class. Let us move on to program 10. Here we need to write a program to blur and smooth an image. As they have not given any restriction on the built-in functions, we can make use of the methods which are already available in different kinds of smoothing functions like box filter, Gaussian blur, median blur and bilateral filter. We can make use of all this and obtain the results on a given image. Let us start with the program. Import necessary libraries CV2 as well as matplotlib, followed by read an image as per the procedure. You know how to read an image. After reading the image, we start with the first function. Let us take a simple box filter concept which can be achieved by dot blur method, which makes use of the input image and the kernel, which is of the size 5,5. This filter smooths the image by averaging the pixels values within the kernel. And moving on to the second Gaussian blur, which mainly used for removing the noise and unwanted details in the image. For that we make use of dot Gaussian blur function. This blur filter actually filters the image Gaussian blur is the method that we are using here. So under that we make use of three parameters. The first one is image to be used, input image, and the kernel size, which is of the size 5x5, and 0. The third parameter is 0 here. It is the standard deviation value in the x and y direction. Here x direction variable is denoted as sigma x and y direction is represented as sigma y. If only sigma x is specified, then sigma y is taken as the same as sigma x itself. If both are given as 0, then they are considered or calculated from the kernel size. Gaussian blurring is highly effective to remove the Gaussian noise which is present in an image. So moving on to third type, which is median blur. You know how to find out a median in a given array. The same thing applies here also. So for that, dot median blur method is being used here, which makes use of input image as well as kernel size 5, and this applies a median blur filter to the image. The parameter 5 here specifies the size of the filter, as I said, and which is more effective for reducing the salt and pepper kind of noise in the image. And this function takes the median of all the pixel under the kernel area, and the central element is replaced with this median value. This is highly effective against salt and pepper noise as in the image. Interestingly, in the above filter, the central in all these filter techniques, the central element is either replaced with the new calculated value or the same value, but in case of median blur, it is one of the pixel value of the image itself, So that's why it is more suitable for salt and pepper kind of noise to remove it. And the kernel size that we are using in all these methods should be positive and odd number always. Either you can take 3 cross 3 matrix or 5 cross 5 or 7 cross 7. The ideal one is 3 cross 3 or 5 cross 5. Moving on to bilateral filter. Bilateral filter is another one more kind of blurring techniques. Here this function applies a bilateral filter to the image, and the parameters what we are using is 3 parameters, that is 9, 75 and 75, which represents the 9 is represented as diameter of the pixel neighborhood, and the filter, the next parameter is filter sigma in the color space, and the last parameter is filter sigma in the coordinate space respectively. This filter smooths the image while preserving the edges. So, and this is highly effective in noise removal while keeping the edge sharp. So after doing all this, we are moving on to display function. Before that, let me just take you through how exactly in the backend these functions are applied. All this blurring functions applied. Let us consider an image like this. You can see the image. The output image looks like this and the input image looks like this. And for a simple box filter, actually there is a convolution happening over here with the kernel value as well as along with the input value, input pixel of the image. Say for example, for the box filter we have taken a simple kernel like 3 cross 3 with the value filled with 1 in the box filter, whereas in case of Gaussian Gaussian blur filter, where here you don't have 1 in all the cells, but here the distribution of the value is something else. It's a little different because we are keeping the highest priority for the center pixel and lowest priority for the border pixels in order to highlight, filter or remove the noises and preserve more informations compared to the simple box filter. So here for the explanation I have taken simple box filter example. You can just see, assume that we are placing this 3 cross 3 matrix on this input image here first time, and in the second time we place it over here, third time we place it over here, and so on. When you start doing this, you can see this red color box where when we place this kernel on this particular location of the image, how are we computing the value is we are finding the product of sum of these values. So the first kernel value is getting multiplied with the first pixel value of the image, plus second value of the kernel is multiplied with second value of the image, plus third value should be multiplied with third value, and so on. When you do it like this, since we have all these values zeros, you will be getting zeros out of this. Only these three will get multiplied with. From that you obtain 90 plus 90 plus 90 as total sum. As per the formula, it should be divided by 9. So it is approximately 270 by 9, which gives you 30, and that 30 should be replaced to the location of this. Instead of 0 you obtain 30, and you can also notice that the 30 is here. That is how the filtering technique works for all the pixels of the image, and it's a convolution process. The same thing happens for Gaussian blur but with a different kernel, median blur for a different kernel, and bilateral filter with a different kernel. Next, moving on to the major part where you are displaying your images output. What is that original image? Display it as per the procedure, and first filtering technique, second filtering technique, third filtering technique, fourth filtering technique. Once all are done, the final job is to close all the windows. Before that, your output screen will wait for key to press. Once that is done, you can close all the windows. In summary, what we have done in this program is, this whole program loads an image, applies the various blurring technique, and displays the original and processed images using matplotlib. And finally, we closed all the windows. I hope you understood the concept. Thank you. The final result looked like this. Since we don't have any noises in this image, we are not able to find out a difference among all these outputs. When you take a image with lots of noises, you can easily identify difference between average, blurred image, and Gaussian, median, and bilateral. Most of the time, a Gaussian blurring technique suitable for most of the images compared to all other techniques. In some specific cases, like salt and pepper kind of noises images, median blur suitable for compared to all other methods, whereas bilateral, similarly bilateral is suitable for some kind of images, whereas Gaussian blur which suits for most of the images, as because this Gaussian blur mainly has the concept of normal distribution. You all know that normal distribution is a bell-shaped curve where the mean is 0 and the standard deviation 1. So you are taking all the samples under this normal curve. That's why most of the time, most of the images are suitable with the Gaussian blurring technique. Thank you.